Saturn, the jewel of our solar system, is instantly recognizable for one magnificent feature: its breathtaking rings. But have you ever stopped to wonder where they came from? Are they the ghostly remains of a long-lost moon, shattered into 1 trillion pieces? Or are they primordial leftovers from the dawn of the solar system itself? The truth is a cosmic mystery story, and today, we're going to solve it. Welcome to Space and Curiosity, your portal to the greatest wonders of the universe. I'm your host, and together, we'll journey 750 million miles to uncover the secrets behind Saturn's dazzling rings. Before we dive into their origin, let's get acquainted with what these rings actually are. They aren't solid, hula hoop-like structures. Instead, they are a colossal, flat disk made of countless individual particles. Imagine a blizzard of cosmic proportions, with trillions of pieces of water ice, rock, and dust, all orbiting Saturn together. The size of these particles varies dramatically, from microscopic dust grains smaller than a speck of sand, to icy boulders as large as a house or even a mountain. This immense collection of material forms a vast, intricate system, stretching out for hundreds of thousands of kilometers. From afar, they look smooth and continuous, but up close, it's a dynamic, chaotic dance of ice and rock, a celestial carousel spinning around the gas giant. This icy composition is key. It's what makes the rings so incredibly bright and reflective, allowing us to see them so clearly even from Earth. So, where did all this material come from? This is where the detective work begins, and scientists have two leading theories. The first one is dramatic, a tale of cosmic destruction. It's called the disrupted moon theory. The story goes that billions of years ago, Saturn had an additional moon, perhaps an icy one similar to its current moons like Enceladus or Rhea. This moon's orbit may have become unstable, or maybe it was nudged off course by a passing comet or asteroid. Whatever the cause, this unfortunate moon strayed too close to Saturn. As it crossed a critical boundary known as the Roche limit, Saturn's immense gravitational pull became overwhelming. The gravitational force on the side of the moon facing Saturn was so much stronger than the force on the far side that it literally ripped the moon apart. It was a slow, catastrophic stretching and tearing, shredding the moon into countless fragments. These pieces couldn't escape Saturn's gravity, so they began to orbit the planet, spreading out over millions of years of collisions and interactions, flattening into the thin, wide disk of rings we see today. So, in this scenario, Saturn's rings are the beautiful, glittering tombstone of a long-dead moon. Now for the second leading hypothesis. This one is less violent but no less fascinating. It suggests the rings are not the remnants of something destroyed, but rather the leftover building blocks of something that was never created. This is the primordial ring theory. According to this idea, when Saturn and the rest of the solar system were forming about 4.5 billion years ago, they condensed from a giant, spinning cloud of gas and dust called the solar nebula. As Saturn grew, it developed a disk of material around its equator, much like the larger disk around the young Sun. From this protoplanetary disk, Saturn's many moons began to form, clumping together through gravity. However, the material in the region where the rings are now was too close to Saturn. The same gravitational forces that would rip a moon apart in the first theory were also strong enough to prevent a moon from forming in the first place. The gravitational tides from Saturn kept the icy particles stirred up, preventing them from coalescing and sticking together to form a large, single body. So, the rings are essentially a failed moon primordial leftovers from the birth of Saturn that have been orbiting there ever since. So, is it a shattered moon or cosmic leftovers? For a long time, the leftover theory was quite popular, but recent data has thrown a wrench in that. The rings are almost 99% pure water ice, and they are astonishingly bright. If they were truly ancient, 4.5 billion years old, they should be much darker. Over billions of years, they would have been polluted by a constant rain of micrometeorites and dark, carbonaceous dust, giving them a dirty, reddish hue. The fact that they are so pristine and bright suggests they might be much younger. How young? Some studies suggest the rings could be as young as 100 million years old. That's incredibly recent. In cosmic terms, dinosaurs were still roaming the Earth when Saturn's rings might have been born. This lends strong support to the idea that a moon or perhaps a large comet, was captured and destroyed relatively recently. Let's talk about some truly mind-bending facts about these rings. While they span up to 282,000 kilometers in diameter, wide enough to fit almost the entire distance between the Earth and our Moon, they are ridiculously thin. On average, the main rings are only about 10 meters thick. That's about the height of a 3-story building. To put that in perspective, if you were to build a scale model of the rings that was the size of a football field, the rings themselves would be thinner than a single sheet of paper. This extreme thinness is due to the constant collisions between particles, which average out their vertical motions, forcing them into a single, flat plane. And here's something that might surprise you. Saturn's rings are not permanent, they are actively disappearing. Particles from the rings are constantly being pulled inward by Saturn's gravity and magnetic field, falling onto the planet as a phenomenon called ring rain. Based on observations, scientists estimate that the rings are losing tons of material every single second. At this rate, the entire ring system could be gone in as little as 100 million years, and perhaps no more than 300 million. So, we are incredibly lucky to be living in a time when we can witness their full glory. Future intelligent species in the solar system might look at Saturn and see just a plain, ringless planet. Our understanding of the rings took a giant leap forward thanks to one of the most ambitious missions in space exploration history, the Cassini-Huygens mission. Launched in 1997, Cassini arrived at Saturn in 2004 and spent 13 incredible years studying the planet, its moons, and of course, its rings, in unprecedented detail. Cassini flew directly through the gap between Saturn and its rings, giving us our closest look ever. It revealed intricate structures, waves, ripples, and propellers created by tiny embedded moonlets. It discovered that some of the rings are actively maintained by the gravitational influence of nearby shepherd moons. It analyzed the composition of the ring rain, confirming that material was indeed falling onto the planet. But even with all of Cassini's data, mysteries remain. We still don't fully understand some of the strange spokes and braids seen in the rings, or the exact mechanism that might have destroyed a moon so recently. The debate between the two main formation theories continues, fueled by the complex clues Cassini left behind for us to decipher. The origin of Saturn's rings is a perfect example of how science works. The more we learn, the more questions we have. So, whether they are the ghostly remnants of a shattered world or the pristine leftovers from the dawn of time, Saturn's rings are a fleeting, dynamic, and breathtakingly beautiful spectacle. They remind us that the universe is constantly changing, and that we are privileged observers of its magnificent, ongoing story. Now I have a question for you. Imagine you could travel to Saturn. Would you rather fly through the vast, empty gap between the planet and its rings, or would you prefer to observe the glittering dance of the ring particles from a safe distance? Let me know your choice in the comments below. And if you enjoyed this journey into the cosmos, please give this video a thumbs up and subscribe to Space and Curiosity. We have so many more mysteries to explore together. Thanks for watching.